So as I said, we want to start from continue from our previous class. So you guys are on record. So in our previous class, we actually talked about how do we examples of using truth tables. How do we negate truth tables? We now know the connectives. That is the conjunction, the disjunction, and then the negation. These are operators in logic that we have used, and you know how to like write the negation of a statement, and also you should be able to do the truth table now of conjunction, negation, and disjunction. You should be able to do that. Here is an example on the shared screen. The example is saying, suppose N is a true statement and C is a false statement. What is the truth value of the compound statement that is given to you? So in the question, they said N is what? N is true. So where I see N, I will replace N with T, denoting true. And C is false. Where I see C, I'll denote C with false. So as you can see in the solution there, I have what? T or F, and the negation of what? T and F. So T or F, what did we say? In the connectives, that if I have what? T or F in disjunction, T or F is equals to what? Let me just scroll there so that you can see the relation I'm referring to. Look at it. I have what? T or F. T or F, that is, T or F is equals to true. So T or F is true. So that is why you have T or F is equals to true. And T and F, T and F, this conjunction there. T and F is where? Is false. So what is the negation of false? If I have the false, the negation of false is going to be what? True. So now you can see that true and true. That is true and the conjunction true, which is the operator there. So true and true is true. So thus the compound statement is true. Have you seen how we have simplified? That is a statement in terms of symbol, denoting that if a compound statement is true, so if a statement, if a statement is true and one statement is true and the other is false, and you have these logical operators that are connecting these symbols, or these symbols representing the statement, then the true value of that statement can be determined. And that is what we have done in this example, that the truth value of that compound statement is true. So as you can see, that's N or C, and the negation of what? N and C. So N is representing true, and C is representing false. N true, C is false. So that has been simplified using the connectives that I taught in the previous class. Okay, so now let's see this one. I may want to hear from you that if suppose that P is true and Q is false, find the truth value of the statement P and Q. So what is that going to be equals to? P is what? Is true, and Q is what? False. So I have what? True and false from the connectives. Wherein you have the disjunction and the conjunction. True and false is equals to what? That is definitely going to be false. So that is definitely going to be false. And so you can see from the solution there That's look at it. P is representing true and Q is representing false. So true and false, that is definitely going to be equals to false. And you does the statement I eat spinach and I am strong is false. That is if P is representing I eat spinach and if Q is representing I am strong. So have you seen how logic is very you can translate if a statement is negative, you can convert that one to a positive statement and you can use it and it's quite useful. Again, we move to the second one. The second one is just saying negation of P. What is P? P, they said, is true. So what is the negation of true? The negation of true is false. So you have false. And another example is the negation of P and Q. So I have P to be equals to true and Q to be equals to false. So the true and false, as per they connect the operators, we know true and false is what? Is equals to false. And the negation of false is what? Is true. So does the statement, it is not the case that I eat spinach and I'm strong. Is what? It's a true statement. I move on to the next example, the negation of P and Q. So we are looking at what? The negation of P and Q. What is P? P is true. So the negation of what? Of true. And Q is false. F. So the negation of true is what? F. And I have what? False. So false and false is equals to false. So that is a false statement. So you can read around it again. I also have what? The negation of the negation of Q. What is Q? Q is false. So what is the negation of a false? The negation of a false is true. And what? The negation of true is false. So that is basically how you can construct truth tables. And there are further examples also. Now, if you want to use the truth table to construct this statement, now instead of you knowing a statement, remember I've told you the validity of what that statement or the truth value of that statement. The truth value of the statement is when you ascribe that statement to be true or false. So if I give you P, say P is a statement, and I tell you that statement is false, so wherever P is, the validity of that statement is F. If I give you, say Q is a statement, and Q, that statement is true, so wherever I see Q, the validity of what? Of Q is what? It's true. So I'll write C to represent that statement. Okay, so I'll stop here and then get feedback from you guys to see if you are following or you getting or if you have any questions to ask. So if you have questions, you can unmute your mic and make a comment, or if you want to share something, you can do that. Any questions so far? Is it okay? Hello, is it okay? So everyone? Okay, so if it's okay, then I want to proceed because I cannot, I've not got any comment from you guys, or if you have a question to ask, and that's the case may be. Is it? Yeah. So we proceed. So now, how do I construct a truth table for compound statements like this? How do I construct a truth table for the compound statements? That's one. So remember, I said if you have a compound statement, P and Q, then the truth table will look like what? It is possible that I have true and true, I have true and false, false and true, and false and false. So if I want to construct truth table for this, then what will I expect? I need to get the negation of of uh, P, and the negation of P is, look at this, true here, it becomes false, true also becomes false, false becomes true, and false also becomes true. And that is the negation of what? Of P. This should be the negation of Q. The negation of Q. The negation of Q. The negation of Q is, I have T. Okay, so the negation of Q, look at Q. I have true, false, true, false. The negation becomes what? False, true, false, true. That's the negation of Q. So I took the negation of P and I took the negation of what? Q. Don't forget, when you have a compound statement, P and Q, what are the possibilities of that compound statement? What do you think that compound statement um, should look like? What will be the possibility? So the possibilities are, if I have a compound statement P and Q, both of them could be true. One is true, the other is false. The first one is what? False, the second is true, and both of them are what? Are false. So that is how I can compose a compound statement and get possibilities for P and Q, because it's only P and Q. Now, the first possibility is saying I negate P. I have to give out the negative of P. So I have false, false, true, and true. Remember, here I see true. I'll replace it with what? False, true, false. The negation of Q becomes what? False, true, false, true. Now, if I want to combine not P and not Q, false and false is equals to what? False. And then what? False and true is equals to what? False. You also have what? False, true and false is equals to false. And what? True and true is equals to true. So I have what? I have I have negated the, or I have done what? The truth table for that compound statement. Okay? I have done the truth table for that compound statement. Here also, say you ask to do the truth table for this compound statement. Construct a truth table for, I ask you, any test or exams, you should construct a truth table for that statement, the negation of what? P. The negation of the negation of P. So if P is representing true and false, P is representing true and false, what is the negation of what? P. The negation of P becomes what? False. For this one, for true, this one, and also for true becomes what? True. So this one for false is true. So I have negated the values, the possibilities of what? The statement. True. So that statement, if I just have one statement, and that statement, I said, what are the truth values of that statement? The two possibilities are what? True and false. So to negate that, I'll get false, and then I'll get true. And then the negation of P, I have what? I have true. And the negation of what? This now becomes what? False. So I have negated it, what is in the bracket. Now I have to negate this one. Here I see true, I'll get what? Here I see false, I'll get true. And here I see true, I'll get false. So this is what we refer to as the law of double negation. The negation of a statement, that statement is true. So normally that is why we say somebody should not repeat double negation in a sentence. In other words, you are referring to the sentence and the true, this affirmative sense of the sentence. Okay? So I still want to get feedback. If it is okay, then I'll continue. If you have something to say, you can say that before I proceed. Ruben, do you want to say something? Unmute your mic to say something. You want to say something?
No,
Are you
no,
okay?
sir.
Yeah, you're okay.
Yes, sir. Yes, sir.
Okay. What about Abubakar? Are you okay?
Yes, sir, I'm okay, sir.
Okay, that's good. So I hope we are doing well. So I'll proceed in the and you guys need to like this is on record, so that's the advantage. I will ensure today I was uploading the previous content, but I'll ensure all of them will go today, so that those who are not fortunate to be part of our class will go to my channel and see what we discussed in class. Okay. So I proceed. I see that we are understanding the content. Okay, so that is it. Now, look at this table. Can someone explain to me, or let's see, you were asked to construct a truth table to determine when the following statement is true. So, when do you think the following statement is true? That is the compound statement. That compound statement is true. When do you think it is true? It's what we would. Okay, so as you say, it's a very long truth table. It's a long truth table. Remember, you first look for what? The values. I have two statements there. The statements are what? P and Q. These are two statements. So remember, what are the possibilities?
I want to ask a question. Is Mr. Seludia?
Yeah, I'm there. Who is this?
Because I've just seen a notification that I'm the host now, so I don't know if Mr. Selu is around.
Yeah, I am the host because it's like Abubakar, are you seeing that? Are you hearing from me? Are you with me? Hello? Okay. So that is it. And you are, yes, the internet is unstable. So that's, yeah. Okay. Are we all together again? Okay. So the internet was unstable. So like I have to, it happens like that. At times it gives some little problem. But the good thing is you guys are online. Okay, please don't forget to mute your mic. They said the internet is not stable, but it's on record. Now look at the question that you have. That you guys need to find a truth table for this. The truth table. How do you get a truth table for this? So the first task that comes to mind is what are the variables I have there? I have P, I have Q. This is what I have. So the truth table for this, I have to write the P and Q, and then the possibilities of those two compound statements. That is, I have true and true, true, false, false, and true, and false and false. Now, see, I have P and Q, so you know what to do with that. I also have what? In this other bracket, the negation is there. Look at it. So I have done this first aspect of the word, negation. I also need this one, P or Q. Look at P or Q. Is there. You have P or Q there. And fitting with Q, you have this one. So when you bring both of them together, so I expect you guys to actually do that on your own, and then you can see exactly what will happen. That is, you can construct the truth table. This table continues. It's not. This is not the end. Remember, your final column of your table must represent this entire statement that you have here, which is what I have here. This one, it must represent that. So you are to construct that truth table, and then you can find the compound statement for that. Okay? So that is how we construct truth table and get compound statement. So before I move to conditional, and then I don't, as you can see in the you have a lot of tables that you have to construct conditional, how you can give the chance, all of this statement you have to, there are two tables here that you construct, so you need to take note of them and ensure that you study very hard. Okay, so I am now on conditional. But before we go again, and we want to ask again if there are polls and ask if there are questions or comments that you might want to share, and if you're getting me loud and clear. Are you hearing me loud and clear? Yeah.
Mr. Salu, we don't get this one clear. Can you go right?
Which one?
This one that you just teach just now.
Okay, so now okay, your mic is mute. Yes. Mute your mic. Just mute your mic. I see.
Because I just joined the class and I don't understand anything.
Yeah, that is it. It's because you just joined the class, and this class is on record, so that you'll have to get the previous notes that I have explained. But what I was explaining is how do you construct a truth table for a compound statement. That was what I was explaining, and how do you construct a truth table for a compound statement, and it's quite straightforward. Let me share that again, and before I proceed to something new. Okay, so what I was sharing is I was sharing that what I shared or what we have learned so far is a quick recap of it is say, remember we have talked about statements. I said a statement is in logic anything that can be true or false. So now if letters are representing statements, you can mute your mic if you're not talking. Please mute your mic. Make sure your mic is mute. Teno and others. Yeah. Okay. So in the case of the you have mute your mic, Lemon. You also mute your mic, Samsung SMNDs. Okay, yes, so, yeah, exactly, that's it. So I was saying if you are giving symbols to represent or letters to represent statements, those statements could be true or false. So one form is that if they say like N is true and C is false, how do you represent that statement? We have solved that question, and we went on to do for other examples as the case may be. Now I am on truth tables that say, for example, you want to construct a truth table for the statement not P and not Q. I said in a compound statement the four possibilities are, say for example, I have two statements here. If I am paid, I will give you your money. So the condition here is if I have money, I'll give you your money. It's possible I get money and I give you your money. So that is true and true. I have done that is one possibility. It's possible I have money, but I did not give you your money. So that is another possibility. It's possible I don't have money on me, but I tried to get money somewhere and I paid you. And it's possible I don't have money and I did not pay you. So the internet is not stable today. It's not stable. It's like disturbing, but I'll be fine. Yeah, but this is all on record, so you'll be fine. And so that is what we have learned today, or we have discussed today. That the possibilities are those possibilities. Our task now is how do I construct a truth table for this? So the truth table is going to look like I have to negate all of P. So what is in P? The properties of P. I have true, true, false, and false. So if I'm getting the negative of that one, there I have true becomes false. Here I have false becomes what? True, and as the case may be here. Again, I want to negate Q. Q, you have what? False, true, false, true. The negation of what? Q. And now I need to combine the negation of P and negation of Q. So I have false and false, that is false. False and true is false. True and false is false. And true and true is false. So the act is true. So those are the truth table there. So that statement is only true when both what? P and Q are false. That's the only time that the statement will be true. That is, P is not true and Q is also not true. That is the only time that statement. Yeah, it's the internet has been a problem. We will proceed, and I don't have much time, but this first aspect of the note is on record. So the only thing you need to do, just like as we did on Friday, is that I will go offline and then I will reconnect again, and then we will continue our meeting. Is that clear? So I will like this is going to be recorded, and I will upload that. So I will go offline and then I'll reconnect again. Then we'll discuss more and more to see if you guys are understanding or you guys are going through the content. Yeah. Okay, guys. Yeah. So let me I'll reconnect again and then we'll continue the meeting. Is that clear? Because it will soon go off the mat. But don't worry, when it's there, I can just go and then join the meeting again, and then we are there. So that is exactly what I want from you guys, so that you can go over the notes on your own. And I know when you'll be looking at it on your channel, or if you after you have downloaded it, you'll see that you will understand it better, and you will find it difficult to go through the entire content. So as I said, my time will go off at any time, but we still have to continue until it happens. So that is it. So you can see that the truth table ends up in that format. Okay, you can also do truth table for this. You can also do truth table for that, and you have this work to do. Okay, so now my next stage is conditional. Conditional statements. These are very important. So we now use what the truth table to prove certain useful results and introduce some additional operators. The first is one will consider is called a conditional. If P, then Q. It's called a conditional statement. It's symbolized as, or it's symbolized by P implies Q. So conditional is like this. Don't forget, you have the disjunction, you have the symbol for conjunction, you have the symbol for negation, you have the symbol for conditional now. So that is conditional. That is where P is called the antecedent and Q is the consequent. So if P antecedent, P, if P is the antecedent, then Q, the consequent that will happen. So P precedes the consequent. So the antecedent and then the precedent. Okay, there are several ways of using a conditional as illustrated by the following example. We use if then to indicate a logical relationship, one in which the consequence follows logically from what? The antecedent. That, for example, if the negation of P has the same truth value of P, then P can replace the negation of the negation of P. So that is it. Another way we can interpret the conditional is that we can use it if then to indicate a causal relationship. If John drops that rock, then it will fall on my foot. If John, that is the conditional. If John drops the rock, that is also another way we can represent a conditional statement. Another third way again, so like I'll give you statements and then I'll ask you to verify if it's a conditional statement or not. Now, we can use if then to report a decision on the part of what the speaker. If John drops that rock, then I will hit. Okay? If John, then I will hit. So that is also another way we can represent that conditional. And also we have, if John drives a Joe, then John drives a car. So it's also another way you can represent a conditional. And finally, we can use if then to make a material implication. If John gets an A on that test, then I am I am a monkey's uncle. Can you imagine? So that is it. So these are always, again, you can link materials to statements. Now, so we have these ones. Now look at these ones.